Hello everyone. So in this particular video, let's solve the questions from the chapter Amines, whichever came in JEE Main 2026. Okay. So nearly there are 12 questions in from this particular chapter. I'll be covering all these questions with detailed video solutions. Okay. So you also just try by pausing this particular video now, and then you can watch the video. Okay. So here they have given this nitrobenzene, all right, and they have given these many reagents, and after seeing these many reagents you might have end up like I can't do this, right? So but if you know what these reagents will do, then this question is really easy. Okay, let's solve one by one. Here let me write it again. Here this is nitrobenzene, right? And in the presence of this Br2, Fe, Br3 and heat. So what happens here, as we know that this NO2 is an electron withdrawing group, right? And it is strong electron withdrawing group. And we know that electron withdrawing groups are meta directing groups. So this reaction is basically electrophilic substitution. Here the electrophile is Br positive. Okay. Let me write the product over here. So here a bromine will get substituted over meta position with respect to this NO2. So here we'll get NO2, and here on meta position bromine will get substituted. And basically the question is asking about the number of bromine atoms in the final product P. So after solving this whole conversion we'll get product P, and we need to tell how many bromine atoms are there in that particular product. Okay, so that is the question. And here, and then the next reagent is tin HCl, and you might have an idea about this is an reducing agent. It will reduce this NO2 to NH2. Okay, so this nitro group will get converts to NH2, and here this bromine will be unaffected, and here the name of this compound will be metabromo nitrobenzene. Okay, so here we have got this is metabromoaniline. And now what happens means, as they have mentioned over here, pH neutralization, you might get confused over here. It's just basically that, see here this reduction is happening in the presence of an acid, right? So what happens, these lone pairs obstruct the acidic hydrogen and it will form NH2 positive, NH3 positive. So basically this neutralization is needed to regenerate this free NH2 group, which activates the ring for bromination. So the next step is bromination itself. So that's why they have given the neutralization also. I am writing here itself neutralization also. After neutralization we have got this particular product, and then further if you don't have an idea about what exactly this one, you can do it directly, because see, anyways this will reduce the NO2 to NH2, that you know, but you can't able to get that thing, right? As it is occurring in as there is an acidic group, it might become NH3 positive. If you don't have that particular idea, anyway you will get the answer itself. Anyway you will get the right answer only, because after treating with this tin HCl you will be writing this product only, right? So yeah, and the next reagent they have given this is a bromination. And here you know that this NH2 group is a strong electron donating group. It is strong electron donating group, right? So as we know that electron donating groups are ortho para directing groups, right? So here NH2 is orthopara directing group, and here this bromine is deactivating group, but still it is also an orthopara directing group only. So just let me know why this bromine is orthopara directing group, in spite it is a deactivating group. Okay, so just let me know that thing in the comment section. So here what happens means, as it is a strong electron donating group, the bromine will be substituted over all the ortho and para positions. So with respect to this particular group, this is ortho position, this is also ortho position, and here this is para position. And yeah, don't think these are free radicals. I have just told you like these are ortho and para positions. Okay, so here what we'll get, here this bromine will get substituted over all these three positions. Now will get this type of product. So now we have bromine on meta position, that will be like that only, and here one more bromine will come, and here one more, and here again one more. Okay, so in the next step, they have given this NaNO2 and in the presence of HBr, and in the presence, so here in the next step they have given this reagent NaNO2 in the presence of HBr at 0 to 5 degrees Celsius. As you can see, after seeing this reagent, you have got an idea like we are doing diazotization, okay, reaction. So here when you do diazotization, what happens? This NH2 will become N2 plus, and whatever the halogen will give here, Br negative. Okay, so here in the presence of NaNO2, HBr will conduct at a less temperature. So here what happens? This NH2 becomes N2 positive and Cl negative. Okay, and here we have all the bromines on. Till here this compound is having 4 bromines, right? Maybe we'll get one more bromine over here in place of this. So that's why they have given further reaction. Bromine, here one bromine, here also one bromine. Okay, and here again what happens? Here they have given this one again. This is the name of reaction, which is Sandmeyer reaction, right? CuBr in the presence of NaBr. Here this simply it will N2 plus and this is Br negative. Okay, so N2 plus and Br negative will get replaced by bromine. Simply we'll get this product. So let me write it over here. Finally we have got the answer. How many bromines are there in this particular compound? 5, right? So here also we have got one more bromine, and initially we have 4 more bromines over here, over these positions. So finally this is the product P, and how many bromines are there? 5. So okay, so I hope you have understood this particular conversion. Just don't get afraid of by seeing all these reagents, but if you know the purpose of this particular reagent, you can easily solve this question. See, let me summarize this question once. So here they have given this reagent. This is generally basically it undergoes electrophilic substitution reaction. As it is electron withdrawing group, this will get substituted over meta position, and then they have given this particular tin HCl and heat. So here what happens? This is just reducing agent. It will reduce this NO2 to NH2, and then further pH neutralization. Why we are doing neutralization means this neutralization is we need this neutralization to regenerate this free NH2 group, because as it is occurring in the presence of acidic group, this might converts to NH3 positive, which will be which will act like electron withdrawing group, right? So that's why we'll be doing this neutralization. Further we will do this bromination over here. As it is NH2 is strong electron donating group, the bromine will get substituted over all the ortho and para positions. And then next step we have did this diazotization reaction. Here simply this NH2 will get converts to N2 plus Br negative, and then again after we have did this Sandmeyer reaction. Okay, this is a Sandmeyer reaction. So here this N2 plus and Br negative will, this group will get substituted with bromine. If they would have given chlorine over here, this group will be substituted with chlorine. Okay, so this is how you need to solve. And finally we have got the product P. Then they were asking simply the number of bromine atoms in the final product, so you can count. There are 5 bromine atoms in the final product P. So this is how you can solve it. So this is how you can solve it. This is a simple question, right? So I hope you have understood this question. And yeah, that's it for this particular video. And if you think these videos are helping you out, please let me know. And really I need a motivation to create even more videos for you people. And yeah, just take care. And yeah, bye, take care.